Hi, welcome to this module of our titration video series. In this session, we're going to be talking about the advanced application dependency mapping options. So you previously looked at basic ADM runs with us in the initial module on ADM. We're going to expand that a little bit more, Remi, to go into more depth into exactly how you can tweak those options to come out with a slightly different output.
Okay, Tim. So what are we looking at? Like 747 flight deck? Or we're looking at something a bit more normal? What are we going towards?
We're trying to find a happy medium. We want to provide a few options, or nerd knobs, as we affectionately call them. We don't want to give you every single thing that you could possibly ever configure. We also don't want it to be quite as simple as, let's say, Tesla self-driving, where you just say go and hope that it gets there. Hope being the...
It will.
It will get there.
So
okay.
Let's be precise.
So what we want to do is provide a few different ways that you can tweak the output of the machine learning algorithms. So right now what we're looking at on the main screen is the workspaces. The workspaces is where we have all of the policy from the different scopes. And you can see on the right-hand side that we have a tool here listed as the default ADM run config. So this gives us the opportunity to actually define some basic settings that every single application is going to inherit when they run ADM.
Like when you say that, the first thing that comes to mind is like, it's like my way or the highway, like kind of no changes, you're done, it's done? Or like, is it flexible? What does it look like?
So this is actually one of the more flexible options inside titration. So you provide suggestions as to how ADM might be recommended to be run in the environment, but it ultimately comes down to the individual workspace owner as to how they would like to generate their policy and analyze their policy.
Okay.
So this really is just capturing, let's say, best practices that you might want to suggest the workspace owners use.
Okay, if I say recommendation, would that sound accurate to you? Or?
Yeah, these are definitely recommendations. Especially as you get to learn your data center, you get to learn your dependencies, you will find that some recommendations make sense to be applied across the board.
Okay.
So when I click my default ADM run config, it's going to show me two major sections that I can configure. There is the external dependencies and there is the advanced configurations. So the external dependencies deals with how the ADM system relates objects in your application to external services or external applications. You can see here, for example, all of the scopes that we have created, and then next to them on the right-hand side, we have this option for coarse or for fine. And this is really going to deal with how deeply we resolve the dependencies inside those different scopes.
Okay, I see.
So for example here, on the services scope, we can see that there are two dependent filters, and we have the default ADM run config set to fine. That means that it is going to try and discover the most fine dependency, or the most accurate microsegmentation rules. And we'll go look at exactly what that looked like in the banking application workspace and see how we can play with these different options to potentially change the output of ADM.
Okay, so I found it cool, the options, but I'm sort of worried in the sense that, do I need to do that to actually get started? I mean, is that like pre-work or is optimization? Like, tell me a bit more about the process.
No, these are absolutely not. When you're configuring your ADM system, you really don't need to start messing with these options to begin with. These are just really optional ways to begin tweaking the output of the results. So on a day-to-day basis, or when you're first initially getting started with titration, you don't need to worry too much about what these settings involve. But as you become more advanced, as you start to use the platform more, you might find some significant use cases for these different options.
Okay.
So if we come back to our application screen here, and we look at our banking core prod application. This is the application that we've been dealing with throughout the rest of this series, and we're getting very familiar with these policies at this point. We can see, for example, the banking app has these relationships to the message queue and the key value store, both two services that are outside of this application and part of the services scope.
Okay, up to there seems straightforward.
Makes sense. Now, what we can do is go to our ADM run config here, and we can deal with the external dependencies between coarse and fine to change exactly how that policy is going to be output. So let's say that I don't want to see those two individual services. Let's say I'm the application owner and I've got thousands of policies that have been created for this application, and I want to optimize some of those policies or hide some of the detail. By changing that from coarse to fine, when the ADM algorithms run, it is going to hide those very, very fine or detailed dependencies and just represent them as one relationship to services.
Okay, I see. So you're saying that it will simplify my policy output to some extent. It might degrade my security posture if I choose that, because I mean, less fine mean more ports open, basically. Yeah.
Pretty much.
But it's a choice that I can make.
It's a choice that you can make. And as you can see, this is the same options as we saw in the global config, but this is on a workspace basis. So if I click course here, you're going to see that it removes those filters from that option on the right-hand side there. And it's also highlighted that I can actually go back to the default config. So if I play around with some of these settings, I've added things, I've removed things, but I'm not exactly sure, and I just want to go back to what the administrator recommends. If I just click default config, it's going to reset everything to what the best practices are.
I see. So that's where the recommendation comes in. It shows up with recommendations. I can change any of them. I can update any of them as I want, but I can come back as well to whatever it is.
Correct. That includes being able to reorder them. So when you reorder these dependencies, it is going to affect the way that they are resolved. And you can also delete some dependencies. Let's say, for example, I never want to create a relationship to the AD scope. I don't want to ever open a policy up to AD. By removing that dependency, Titration will not ever create a policy to AD in this particular workspace.
You're beating on Windows again.
Yeah, I have a real beef with it, unfortunately. So we're going to click Submit ADM Run.
You forgot to put it back to course.
You are correct. I really should pay attention to that.
Yeah, you should pay attention, yes.
We've diverted from the default config. I'm glad you're here with me. And we're going to submit the ADM run. So while the ADM run is ticking away in the background there, maybe you could visualize for me on the whiteboard exactly what it is doing and the difference in the policy output that we're expecting to see.
Absolutely. Let's have a look at that.
And I'll bring the policy up here that we're going to be dealing with and what we're expecting to change.
Okay, because you don't know the ports off by heart, that's what you're saying.
I don't remember the ports off by heart. Why do you think I used Titration?
Okay. Okay, let's have a look at that. So what do we have here? We have a scope, and let's say that the scope here, in my perfect rectangle, not parallelogram.
That's rectangle. A nice rectangle.
So this is, no, it's not core, sorry, in this one. It's shared services?
Yes.
Okay. So let's call it shared. We'll call app here. App is connecting down, and then inside the shared scope, I'm going to have message queue and key value. So that's the current configuration. What did we do in the current configuration? So in the current configuration, as we set it to fine, dependencies is going from app directly to message queue, and from app directly to key value. And it's going to use the right ports. So message queue 5672, and key value store 6379. Read this. 9 is better than 3. It's a whiteboard. I mean, I can make as many errors as I want.
Do whatever you want.
So that's the current model. And that's pretty nice from a security standpoint. You're nice, sharp, precise, one port, one service. Pretty cool. But you can also imagine how this can actually span pretty dramatically. Like I could have hundreds of ports showing up in that environment, which would not be fantastic. So what are my options? Well, my options is to actually say course, and that's why we built in this option. And in the course option, what we're going to do is to say, well, look, I see your environment, I get it, but I want to set a relationship from app to shared. So I'm going to a scope, not to a cluster anymore. Or in this case, external dependencies there. Why am I doing that? Well, that's one policy now. I have one policy which 5672 and 6379 applied to it. So one policy, two ports. What's the downside of doing that? Downside is come down to security. If you look at the security problem here, I'm actually having 5672 and 6379 open to MQ. And I also have here on this guy the 5672. So I'm actually opening more traffic than strictly required on those nodes.
So you're basically taking a trade-off somewhere between the complexity of the policy and the detail of the security or the detail of the rules that you're going to enforce.
Absolutely.
Okay.
And the idea is to move in steps. So you could say, hey, you know what, I'm actually going to start with the scope. And you get a huge amount of ports potentially going down to shared services, which is okay. Now you can start targeting and saying, okay, out of those ports, I'm going to expose this service or this service or this service. And as I do that, I'm going to go and create those dependencies. And I'm going to go find again. And as I go find, then I'm going to restrict communication. You can do that in iterations. Nothing forces you of going one shot across the environment.
Okay, so I can run ADM once and see what it looks like with coarse dependencies, and I can run it again with fine dependencies, and I can compare the output between the two and decide exactly as the end user what I would like to go forwards with when I go to policy analysis and policy enforcement.
Exactly. And your trade-off, as you said, is around how much security am I willing to attain versus simplicity. Simplicity, okay. 1 rule, 3 ports. Security, 3 rules, 1 port per rule.
Sounds good.
Sounds easy.
Sounds easy. Well, it looks like the results actually are available, so we can take a look at those and see how it has changed the policy that we were working with. Now, if we just take a look here, we can see it says banking app to message queue and banking app to key value store. This was when we had the fine dependency enabled. And if we click results available, it's going to bring us to the new set of policies. So by changing over to this, we can see a clear difference in the output. Rather than there being 2 individual lines per service that we were using, there was now just 1 line representing both dependencies. And you can see it has both 5672 and 6379 in that 1 individual policy intent there.
Perfect. So policy simplified, security diminished a bit.
Yep.
But maybe that's the call that you've made from a security standpoint.
Yeah. So that's the option we really provide. And that's the option that you will want to come to understand and really play around with so that you can become comfortable with what those different settings mean.
Yeah, and remember, keep in mind that it's not because we allow the policy to go through that there is a process listening on the other side.
That's very true.
So you could have NTP, but NTP might not be listening on 123. So if you open 123 to a server with NTP, if the port is not listening, there is no connection. That's the trade-off you have to think about, like the risk-reward kind of thing as usual.
Well, I'm just glad at least we have the option there to be able to modify the policy. So we looked at the external dependencies and the way that we can change coarse to fine or fine to coarse and come up with a different output. Let's now move past the external dependencies and delve into the advanced configurations at the bottom here.
Let's delve, Tim.
So here we have basically 2 major parts to the advanced configurations. There is the sliders on the left-hand side, which we'll get to. And then on the right-hand side, there is a set of checkboxes that either enable or disable a particular feature that the machine learning algorithms will deal with. So I'm going to work from the bottom up. We'll start with skip clustering, and we'll get to ignore flows matching any of the exclusion filters.
Sounds good.
So skip clustering and generate policies. What does that sound like to you?
For me, straight up more work. I mean, that's how I see it. I mean, your machine is going to do less. I don't like that.
Yeah. It is in many ways disabling some of the background machine learning that's happening. It's saying, don't do the clustering, which we talked about in the application dependency mapping module. I want to provide the clusters to you ahead of time. And what kind of situations do you think might be useful to do that?
I'm thinking about situations, but they seem to me a bit away from micro-segmentation technically. I mean, obviously people deploy segmentation as they want, but maybe migration, subnet to subnet, something like that?
Exactly. This particular flag here is useful when you're not trying to get to micro-segmentation. You don't want to actually get those detailed micro-segments generated for you. But you know some segments in your network that already exist, and you want to work out how those segments are communicating. So like you mentioned, it could be, how is this subnet, which I could provide to iteration speaking to a destination subnet?
Could it be because, you know, there's whole GDPR stuff going on, and interpretation, as usual, is very flexible. It's like there's always the same thing with those things. I heard some customers' interpretation saying, well, we want to restrict assets in Europe communicating to assets in the US, in Asia Pac, in any other region in the world. So in that model, if I understood the feature right, I would define what is Americas, I would define what is Europe, I would define what is APJC, and I would just tick that box, and that would actually handle it for me.
Correct.
Okay.
So typically has less use cases on a day-to-day basis, especially if you're trying to do application-level microsegmentation, but it's there as an option for you to be able to disable that feature if necessary.
I see.
As we then step up, the next three really do deal with advancing the ADM algorithms. So the first one, enabling service discovery on agents. So when we're talking about certain particular applications, some of them use very wide port ranges.
I'm waiting for you to bash on Microsoft. Go on.
So one of my favorite vendors, Microsoft, of course, does use a lot of dynamically negotiated ports for a lot of applications.
So you're talking about the famous RPC.
Exactly. We see RPC all over the place, and a lot of Microsoft workloads have that. It's not only Microsoft workloads. There are some other workloads that often have those port ranges open. Hadoop often, for example, is using dynamically negotiated ports as well.
Wow, Tim.
I know.
Yeah, you're making progress. I'm impressed.
So here, if we're looking at enabling service discovery on agent, what that allows us to do is capture what a particular application is doing without having to see flow data. So let's say if we're on a server that is using RPC, we will query the server itself to say, what are the RPC ports that you expect to be using?
I see. So you're looking inside the Windows system. You're asking Windows to report which RPC services which RPC port ranges it's actually using, and so you can actually anticipate the behavior of the Windows platform. Is that about right?
That's exactly what we're doing. You know, a lot of Tetration's discovery is based on flow data, but as you're looking at something like RPC, which might have tens of thousands of different ports that it's listening on, statistically it becomes unlikely that you will see every single one of those ports. So it makes sense to be able to query the system and say, this is the actual range of ports I am going to be listening on. Please put those into the policy. And that's what that's going to do.
That makes sense.
So that really helps with Microsoft workloads. It helps get you a jump start in the policy for those workloads.
Okay.
The next two really deal with how we generate those policies based on the flows that we've seen. So the second one from the top here says carry over approved policies. So carry over approved policies allows us to keep those policies that we put the thumbs up on. We were looking at that in the workspace overview section, and it basically allows us as the end user to say, I'm happy with this policy, I want to keep this policy forevermore.
I see. Do you mind just showing us which thumbs up you're talking about? You know, there's two of them, that's why I'm asking.
That's a good question. So there's a thumbs up that relates to the cluster itself. You can see that this cluster has a thumbs up.
Okay.
And there is also a thumbs up that relates to the actual policy.
Okay, I see. And the one you're referring to here is a thumbs up for the policy.
Correct.
Okay.
So if I want to make sure that no matter what happens in the future, whether this traffic stops flowing or there is a break in that traffic or for whatever reason, always keep that policy in place. Even as you continue to iterate those ADM runs, I want to keep that one in the system. So we have the option to carry over approved policies. And then finally, one of the most interesting options that we have here is to ignore flows matching any of the exclusion filters.
Okay. What is an exclusion filter?
So we looked at it a little bit in the module on policy analysis. Exclusion filters, in short, allow us to exclude certain flows from the ADM algorithms. It asks them to not bake those into the policy output.
Okay.
Now, we can define exclusion filters by hand. That might be, for example, if we delete a policy that we don't ever want to see in the system, or we could just go ahead and create them ahead of time before we run ADM.
Okay.
But one of my favorite exclusion filters that we can actually generate in Tetration is automatically derived exclusion filters.
I like that first word, come on.
Anything that starts with automatic is what you like, right?
I remember the happy bear in the water, that's my motto.
Yeah, more automatic means you can get home faster and you can start relaxing earlier. So what that means is it's going to actually look at the policies that are being inherited to this workspace. and they are going to automatically be removed from the ADM output. Okay.
Okay, so you're saying, if I understand right, in the scopes module you were talking about, there's a higher level and you can have multiple levels inside the scopes. If I define at the top level, allow port 123 to my corporate NTP server, basically you don't want that to come up again in the subsequent workspaces. Is that the logic?
That's absolutely it.
Okay.
We don't want to keep repeating the same policy over and over, and it keeps the actual application workspace neat and tidy and devoid of any policies that are actually infrastructure specific.
I see.
So if we take a look here at our policies,
I see 20.
we can see 20. And if we take a look at our conversations tab, which if we remember from our policy analysis module is going to show us exactly who has been communicating to whom. And if I look at that, some of these conversations, they actually have a little red icon next to them.
Yeah.
So this means that that actual conversation has not been baked into the output of the ADM results. So you can see there's actually quite a significant amount of communication that the components of this application are part of that are not really actually going to be in the output of ADM. There are things like talking to DNS servers, talking to Tetration. Those kind of things have already been handled by our global policy set, so why recreate them in the ADM output?
Okay, I see. So anytime I see those little marks on the side, I should either go and look at my hierarchy of workspaces, or I should look at my exclusion filters I've created. Is that what I should look at?
That's it.
Okay.
In fact, you can even see when I click on one of these exactly why was that created. And it's because there is a global policy that says we are allowed to access the services on port 53, both TCP and UDP.
Very nice. That seems practical.
Yeah, this really actually makes handling real production policies at scale very, very neat and easy.
So if I start at the higher level, I define all my common stuff, Windows machines talking to Active Directory, or Linux talking to syslog servers, that kind of stuff. I put them right at the top. And then after, all the subsequent workspaces don't need to have it again, which means if I need to modify something, I modify at the top. I don't need to modify anywhere else.
Absolutely.
A bit like the variables in programmation if you program right.
Yeah, if you program right, which we probably don't do, but
of course not.
So let's go and actually see what happens if we were to run it without that flag checked and see the impact that it has on the output of that. Remembering that we had around 20 policies in this application that specifically referred to only unique communications in this application and nothing that is to do with the shared infrastructure.
Okay.
So we're going to uncheck ignore flows matching any of the exclusion filters and submit the ADM run again.
Okay.
While it does that, could you maybe visualize that on the whiteboard for me, exactly what it looks like to have these global policies coming down?
Absolutely. Let's remove those ones. I think we were clear on that. That's a squeaky noise, obviously. Yep. Okay. Let's say in our environment, let's take if you're coming to a new Tetration cluster, you're going to have your root scope. The root scope is at the top of the environment. Let's call it default for the sake of this example. We're going to define some rules in default. Default happens to be, let's say, usually the workspace that guys like InfoSec tend to play around with, control, because they actually control rules across the whole environment. So they're going to define things like, for example, HTTP to internet is blocked, but HTTP to proxy is okay. That's the kind of rules you'll see defined in those workspaces. Very, very simple sets of rules. They will always be tag-based usually. They're never based out on like ADM results and stuff like that. Now let's say that I come in, just like you, Tim, and I go and I see my banking core app. So I have my scope, and this one is the core. And I'm going to go and define some stuff inside the core. And I'm going to define my application-specific stuff. So, I don't know, what do we have? Web to Redis, app to Redis.
Yes.
App to Redis, okay. And if I do app to MQ, let's say not OK, just for the sake of example in there. So there's one OK, one not OK in each one. When I have your magic option ticked on the box, the rendering will look like, okay, basically 1, 2, 3, 4. Those policies will actually go there. That's with the box ticked. If I remove the tick box, actually those guys will not be taken into account and they will be rediscovered here. And that will probably show you only the HTTP to proxy.
So if I had policies up in that global level workspace that said everyone can access DNS servers or everyone can access Active Directory servers, by unchecking that box, they would also appear in that lower part.
Exactly. They would be rediscovered. I think it would be probably the best term for that.
Yeah.
The problem is that if you don't tick that box, is that it won't mirror the actual intent that the InfoSec guys had. Because what was the intent of the InfoSec? Deny HTTP to internet, allow HTTP through proxy. The discovery that will be done here, as it doesn't know about the previous workspace, will be, well, allow HTTP to proxy, but actually doesn't know about the intent of the deny. Does that mean that the enforcement is not happening? No. Enforcement is happening in any case, as per those rules, because policy hierarchy that you've seen in a different module applies in that environment. But you might have a harder time getting on to, okay, why?
Okay. Thank you. That makes a lot of sense. And I believe that we actually have our ADM results available to us as well now. So let's take a look at the ADM results. So we'll come up here and choose results available. And it's going to show me that there are some new policies. These policies here are supposed to be filled out with some stuff. We're going to have to rerun it on a new workspace because I remembered that we've created a workspace that's been around for a while that's actually saved that setting. So we'll create a second one, banking secondary, and we can run that ADM algorithm again.
For 1 second, I had read like baking secondary. I was like, why are we in the baking?
It'd be nice if we
now?
could be cooking something.
Yeah, I could do with some like nice French bread.
So let's run that one now and see what we can get. In fact, this will give us an opportunity to have a side-by-side option.
Comparison.
Yes. And now I'm remembering why it's not excluding those features is because we had a primary workspace. So primary workspaces will always inherit those policies down from the global workspace.
Reminds me of a discussion we had just before.
Yeah, it does. So we can wait for this banking secondary one to finish up generating those policies. So we know that if it's in primary, it's always going to inherit the policies from the workspace above. If it's in secondary, you can choose that based on ignoring flows or creating the exclusion filters. And so while that's happening, we can talk through the cluster granularity, port generalization, and policy compression features.
That sounds like lots of options again.
Yeah, some more options for us to play with. So, cluster granularity. Let's talk about that a little bit. Cluster granularity gives us the option to decide exactly how detailed do I want my microsegments to be.
Okay.
So if you remember back in the session on basic ADM, you were showing me how the machine learning was working.
Yeah.
And in that, we were talking about the distance between the different endpoints.
The variation of distance, absolutely.
Yeah. And what cluster granularity allows you to do is decide at what point am I going to decide that these endpoints are too dissimilar from each other and that they should actually be split up into separate groups, or perhaps that they should be grouped together.
I see.
So if I have the cluster granularity set to very, very fine, the endpoints that are going to be grouped together, they have to match each other very highly. They have to be almost identical.
I see.
If I'm looking at a set of web servers, they all have to be web servers listening on the same port. They have to be running the same process. They have to be behind the same load balancer. On the other hand, if I switch it to, let's say, very coarse, here it's going to allow us to group endpoints together that might not be exactly the same. So let's say that I have web servers, but they're different types of web servers. They listen on port 80, but one of them is Nginx, another is Apache, another one is a Java web server. By setting the cluster granularity to very coarse, it's going to group them together into one segment.
Okay, so the more I play with that, like the more groups I would have, or the less groups, right? In short, and the more endpoints per group I would get.
Pretty much, that's
Okay.
it. On the left-hand side, you'll have less groups with more endpoints in them. And as I move it to the right, you're going to get more groups with less endpoints in them.
Okay.
We can then step up to port generalization.
Maybe before we move forward, is there a recommended setting that you would recommend to a customer that wants to get started?
Well, like everything, it's very difficult to give a concrete recommendation for this. Typically, I would say start with medium.
Okay.
That's where it will be by default. Take the results of the output, see if it makes sense to you. Is it splitting things up too much? Is it not splitting up well enough? And then play with this.
Okay.
It's an iterative process. You can run it a couple of times over and over to see what the output of the system is.
Okay, sounds good.
On top of that, we can then begin to move to some of these other features. So port generalization allows us to take a range of ports and collapse them down if we see some similarity between those ports.
Okay.
So let's imagine that we do have a system that is dynamically negotiating ports, something in a range of 1,000 ports that it potentially could speak over.
Let's see. Do you want me to actually mark the ports down to maybe make things clearer?
Yeah, that could be really good if we do that
Sure.
on the board as well.
Let's do that on the whiteboard then. So I'm just going to retranscribe what you said in there. So let's say I have a system and it has port 1, 2, 3, 5, 6, 7, let's say 10, 11, something like that?
Something like that.
Okay.
A range of ports. Maybe not every single port in that range has been seen previously in the past based on flow data.
Okay.
So here we have a range from 1 to 11 with some gaps inside that range.
Yeah.
Now, if I have port generalization set to disabled, what we will see is that the ADM output will list each one of these ports explicitly.
So you would have something like 1, 2, 3, 5, 6, 7, like that would show in one ADM.
Yes.
Okay.
That would be the output, which is highly secure, potentially even too secure. Let's say that, for example, we might in the future see port 4 and port 8 in that range. If we go that detailed, they will never be opened because of the fact that we enabled whitelisting.
I see.
So let's say that the real intent, our desire, is to open ports from 1 to 11.
Okay.
So by changing this port generalization slider, moving it from disabled through the aggressiveness all the way to very aggressive perhaps, it is going to look at ranges like that, and as soon as it starts to see gaps, but small enough gaps, it will actually group it into one large output. So it would say port 1 through to 11.
So you get one basically big range instead
Yes.
of multiple ranges. Okay, middle the ground then, because obviously middle ground.
Middle ground is good. You can start with moderate. I might even say that you could begin with aggressive. This is a good feature to be able to optimize policy, and typically when we do see those ranges, it does mean that that server is actually trying to use that range and it's not just a coincidence. So opening it up faster is usually a recommended way to deal with that.
I see, okay.
Yeah.
Cool.
And then finally, as we've got through port generalization, we're now able to look at policy compression. So policy compression is another way of being able to optimize the outputs of ADM. So when it's disabled, policy compression is disabled. It's not going to do anything. That makes sense, right?
Surprising.
Surprisingly enough. However, when we have policy compression enabled, whether that's moderate or very aggressive, what it is going to attempt to do is notice when many components of an application are talking to the same dependency.
Many components of application talking. So you're thinking DNS or NTP or stuff like that?
Exactly.
Okay.
Let's say that we have all of the parts of our application talking to the same DNS server. If you have policy compression disabled, each cluster will have an individual policy to that DNS server.
Okay.
So basically, the more clusters you have, could be a couple of clusters, could be tens of clusters, you're going to increase the amount of policies, but they're all replicated. They all do the same thing.
So if I think of the previous app you had, it had app and, for example, web.
Yep.
If I have DNS and NTP, I would have DNS and NTP from app to shared service, and DNS and NTP from web to shared service. And
Yep.
what you're saying that if I modify this slider, it's actually going to compress them and say, okay, this scope maybe to shared service allow 1, 2, 3, and 53.
Yep.
Okay.
And that's really a good way to also reduce the number of policies that you see in the workspace. It makes it much nicer as a human to read those policies, and it does have the benefit of being more scalable.
Definitely. Okay.
So now we've looked at the sliders on the left-hand side. We've looked at the different options that we can select on the right-hand side. If we are wanting to modify the clustering algorithm, which in most cases I would say you don't need to do, you can change it to either just look at flows or just look at processes. Although unless you have a specific use case to do that, I would recommend that you keep it on the default of flows and processes.
I don't believe I've seen any customer making a change in their production environment. I don't know if you have.
No, not myself.
Okay.
We always keep preaching that the more data that you pull in, the more accurate the results will be. So it's clear that having flow data and process data at the same time is going to be better.
Sounds good.
We also have the option to import configurations of load balancers. We're going to talk a little bit more in another section about exactly how we can integrate with some load balancers like F5s and Citrix.
Sounds good.
So we can finally come to our ADM results for this.
Just before you dropped one option.
Oh, did I?
The root tags.
I should really listen to you before we move on. We can look at the root tags here.
The final option of the page.
Yeah.
So, Tim, what are root tags?
Well, how often are you using root tags these days?
I actually never use them.
Yeah. So root tags was a feature that we had that was early available inside Titration. It was useful when we were more network-centric as a product. It allowed you to be able to stop clustering across segments or network boundaries.
Okay, I see. So basically you would import your IPAM, but not for tagging purposes, but basically just for ADM grouping purposes.
Correct. If you didn't want to group endpoints together that crossed a particular subnet boundary, you could upload those subnet boundaries to the system.
I see.
But as you've seen, because of the way that we scalably enforce segmentation at the host, and the fact that it doesn't matter whether we cross subnet boundaries, we found that this feature has in many ways become a deprecated feature. And I would say that you probably don't need to actually use root tags anymore.
Would it be fair to say that anyway today, most likely the actual tagging structure replaces that?
Yes.
So, okay.
Exactly.
Very good. One less option.
So now we've gone through that and our ADM has completed, and we can even see the output. It says 40 here, which is what we were hoping to see. So now we can see that it's created all of these policies. It's created policies to the services on UDP 53 and TCP 53. It's listed everything that was previously hidden by having that exclusion filter enabled. So if we compare this workspace, it's got around 40 policies in total. It's a little bit harder to read because there's so much there that's not really pertinent to this application. It's just part of keeping this box really alive, let's say. So if you look at this one, we have 40 policies here, and if we go back to the alternative version and look at this one, this will only have 20 policies listed. So from my perspective, and I would imagine from your perspective as well, reading through this, it's much clearer to understand exactly what's happening because we've excluded those shared services.
Okay, I'm a lazy bear partisan, right? So
yes.
For me, it's like, if I don't need to repeat, I'm happy. And I think what you're showing actually enables just no repetition, basically.
Exactly.
Okay.
There's no need to repeat yourself. So we would say, unless there's any particular reason to uncheck that box, we would definitely recommend enabling those exclusion filters.
Sounds good, Tim.
So we've been able to go through all of our advanced ADM run configs here, both the external dependencies and the advanced configurations, and cover exactly what the different components are and how we can use those to output or change the output of ADM. But as we mentioned at the start of this video, these are optional. You don't need to play around with these. You don't need to know what each one of these sliders does to start getting useful information out of the Titration system.
Sounds good, Tim. I mean, that was pretty complete. I mean, quite a bit of options to change stuff, but not required.
Yeah, definitely.
I like that.
So you have the nerd knobs, you have the power, but you don't always have to use it.
Yeah, I have the lazy bear option. I'm cool with that.
We'll go with that one to begin with. All right, well, thank you for joining us in this session. If you would like some more information about Titration, please do visit cisco.com/go/Titration.